Good afternoon, chemistry students. This is Schweitzer, and a little quick video on a pre-lab for a section of can we drink some water? Is the water safe to drink? And we're going to use gravimetric analysis to analyze this particular sample for lead ions. Lead ion is going to be lead Pb2 plus ion. So what we'll do for this lab is simply take a sample of lead ions. This lead is labeled as well water or sample of water. Let's say at this point Flint, Michigan is having issues with water right now, so we call it Flint, Michigan water. And we would take a small sample of this water using a graduated cylinder. We would measure out a very specific amount. I think it's asked the lab for take about 15 milliliters. Of course, that amount is important. We're going to try to determine the molarity of the unknown water. So my volume is going to be 0.015 liters. I need to know the moles of this to divide to get the molarity of the lead ions. So now we have our sample measured out in a beaker of 15 milliliters of our lead ions. At that point, we will then take some sodium chloride. Now you'll find a beaker of sodium chloride on your desk, and you might see some solid on the bottom. It's quite concentrated, so it has maximum solubility at this point. And you'll see a pipette in there, and all we're going to do is simply take and pipette into this thing several pipettes. A pipette is about 5 milliliters, so we'll do 3 to 4 pipettes, and you'll notice that at that point you will get a beaker with quite a bit of solidness in here, and it'll look quite white. Given time, this thing will in fact settle out, and you'll find the bottom will have lead chloride. I'm interested in the lead ions. The equation for this is PbNO3 plus NaCl yields PbCl2 plus NaNO3. This is the molecular equation. The net ionic version is just Pb2 plus Cl minus, two of them yields PbCl2. So for every lead chloride present, there was one lead that was originally present in the original sample, which came from someplace else. So what I want to do next is take my sample of my lead chloride, keeping all the lead here, and I'm looking to filter out the lead chloride, and usually would use some sort of vacuum filtration for this. You should be familiar with that. And then the end of the hour, we'd have a filter with all of the lead chloride on this particular piece of paper. Let it dry, and in the end we would have a mass of PbCl2. From that, you should be able to, with stoichiometry, say, well, how much lead was there? For every 1 PbCl2, there is 2 chlorines and only 1 Pb lead ions. So you have an option at this point to take a percent by mass issue, or you could go strictly with stoichiometry and figure it out that way. You could say, well, I'm not going to give any more of that. We've done some of this already in class. I'm assuming at that point you can figure out from either of these methods the moles of lead ions present there. And with that, you will complete the circle, and those moles will come up right here and get stuck in to figure out your molarity of your original solution. And that is it. A couple things. You just, again, reminder, you will measure out, very accurately measure your lead sample, probably do 2 of them, adding in the concentrated NaCl, of course, we don't really care what the concentration of it is. This is the excess reactant. Okay. Other than that, that's about it. Thank you very much.